Friends, before talking about prime numbers, so we are dealing with prime numbers here. If I take natural numbers, I am taking natural numbers here starting from 1. Based on factors, we can divide the natural numbers into 3 categories basically. So they are, suppose if you take natural numbers n, I am dividing into 3 categories. First category is prime numbers. Second category is composite numbers. The numbers which are not prime numbers are, I will tell you afterwards what is the definition of prime number, what do you mean by composite number, and number 1 is the third category, because 1 is neither prime nor composite. I will tell you what is a prime number, what is a composite number. 1 is neither a prime or nor composite. That means when we are talking about prime numbers or composite number, we start from 2 actually. Okay, what is a prime number? What is a prime number? Prime number means no factors except 1 and itself. So if you take the factors of the prime number, you will not have any factors except 1 and itself. Okay, so the numbers which are having no factors except 1 and itself, they are called as prime numbers. So obviously you know what is a composite number. I already told you which are not prime are called as composite numbers. So composite numbers means extra factors also will be there. Extra factors other than 1 and itself. That means minimum 3 factors should be there. Minimum 3 factors. If minimum 3 factors, in the 3 factors also 1 and itself, apart from 1 and itself, if you have some extra, at least 1 extra factor if you have, that number is called as composite number. So 1 comes here. So 1 is neither a prime nor a composite number. So it is still in research, right? So whenever we are talking about prime and composite numbers, we should not talk about 1. Okay. So clearly I have written for your convenience. Now we will discuss what are the properties, how the questions are coming in the competitive exams. Clearly for your convenience, I have written some prime numbers from 1 to 100. This is also one important point that you need to remember. So 1 to 100, how many primes are there? 1 to 100, see clearly 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So clearly from 1 to 100, if you start from 2, 1 is neither a prime nor a composite number. So definitely there will be 25 primes. 25 prime numbers will be there from 1 to 100. If you take 1 to 100 domain, 25 prime numbers will be there. So that means that 25 prime numbers does not have any factors except 1 and itself. So out of that 25, from 1 to 50 only you will find 15 primes. So from that 1 to 100, from 1 to the first half, in 1 to 50 only you will find 15 primes will be there from 1 to 50. So okay, so this in a nutshell, this is the explanation of a prime. What is a prime number? A number which is having no factors except 1 and itself, they are called as prime numbers. So whenever we are talking about prime numbers, since 1 is not there, the prime or composite family starts from 2. Prime family starts from 2. Okay, now we will discuss what are the features that we should know regarding these prime numbers. Okay, now in these prime numbers, the first number that you should know in prime family is 2. Friends, there are some specialities regarding 2. 2 is the first prime number. 2 is the first prime number. Least prime number. If anybody asks you what is the least prime number in the prime family, anything that is the first or least. So first prime number, least prime number is 2, and the third important point is only even prime. 2 is the only even prime number. You can see clearly I have written 25 primes. There are 25 primes from 1 to 100. You can see all the remaining primes are odd numbers. 2 is the only number where you can find an even status in the prime family. So 2 is the first prime number, or sometimes logically they can ask you what is the least prime number in the natural number family. So you can say that is 2. So first prime number, and it is the one and only even prime number in the prime number family. Remaining all the prime numbers are odd. Okay. So this is the first point that you should know. And secondly, all the prime numbers all the prime numbers end with 1, 3, 7, 9 except the digits 2 and 5. This is very, very important point. So all the prime numbers you can see, odd numbers. So you can say, sir, 5 is also there. So all the prime numbers except 2 and 5. You leave 2 and 5. Except 2 and 5. You take any prime number, they will end with 1, 3, 7, 9. They will end with 1, 3, 7, 9. This is the first. That means we have got 10 digits from 0 to 9. So first of all, the basic priority, if it is a prime number, the most important thing is it should end with 1, 3, 7, 9 except the digits 2 and 5, because 2 and 5 are somewhat special. Because any number which is ending with 2, any number just like 12, 22, 32, 42, 52, 62 like this, if you take this number, they are not prime numbers. They are having some extra factors other than except 1 and itself, right? So any number, but single digit 2 is a prime number. Any number ending with 2 is not a prime number, but single digit 2 is a prime number. Similarly, the same status goes for 5 also. So any number ending with 5, 15, 25, 35, 45, 55, they are not prime numbers. But single digit 5 is a prime number. That's why I said all the prime numbers end with 1 or 3 or 7 or 9 except the single digits 2 and 5. This is very, very important point. And why 2 and 5 are? 2 and 5 will make so many miracles. Like whenever you multiply 2 and 5, you get the first valid natural number with 0 in the ending, that is 10. So we will get so many things, we will know so many things regarding this 2 and 5. When you multiply 5, the first valid natural number with 0, that is 10, will come into the picture. Like that, so many things. So 2 and 5, except for now in this session regarding prime numbers, all the prime numbers end with 1, 3, 7, 9 except 2 and 5. Except the single digits 2 and 5. Now we will go to the next feature. Now the next feature that will be very useful to you in solving the questions in the competitive exam is, if you take a prime number, if you are claiming a number to be a prime number, they will be in the form of 6n plus or minus 1. That prime number will always be in the form of 6n plus or minus 1 when p is greater than 3. When the prime number is greater than 3, that means it starts from 5. So 5, 7, suppose if I am taking, so up to here I am not taking greater than 5, if I am taking 5. Can you write 5 in the form of 6n plus 1 or minus 1? You will say yes, 6n minus 1. So n is equal to 1, 6 into 1 minus 1, that is 6 minus 1, that is equal to 5. Okay, if you take 7 we can write it as 6n plus 1, so n is equal to 1. So like that, so 6 into 1 plus 1, that means 6 plus 1, that is equal to 7. So if you take 2, 6 into 2 plus 1, that is 12 plus 1, that is equal to 13. 13 is a prime number, you can see. And if you take 17, suppose if you take 17, 6 into 3 minus 1, 18 minus 1, that will give. That means whenever you are claiming a number to be a prime number, it must be in the form of 6n plus 1 and 6 or 6n minus 1, provided if that prime number is greater than 3. But my dear friends, don't get confused here. The vice versa may be true, may not be true. Okay, the vice versa may be true, may not be true. If you say, sir, I will take any number in the form of 6n plus 1 and I will claim that number to be a prime number. No, it is not possible. It is not possible, right? Suppose if you take 6 into 15 plus 1. 6 and plus 1, 6 15s are 90. 90 plus 1 is equal to 91. 91 is not a prime number. 13 7s are 91, right? So if you are claiming a number to be a prime number, if you are telling it is a prime, if you are confirmed it as a prime number, it must be in the form of 6n plus or minus 1, provided that prime number is greater than 3. But the vice versa may be true, may not be true. You should not say that I will take any number in the form of 6n plus 1 or 6n minus 1 and I will tell this is a prime number. That can be true or cannot be true. That depends upon the given number. Okay. So once again I am saying any prime number, that means first of all you have to confirm that it is a prime number, or if you are claiming it to be a prime number, it must be in the form of 6n plus 1 or 6n minus 1, provided that prime number is greater than 3. Friends, here there is a question given on prime numbers. The question is, if n square minus 33, n square minus 31 and n square minus 29 are prime numbers, basically these three numbers are prime numbers, then the possible value of n, if n is a positive integer, should be dash. There are four options given to you: 5, 15, 6 and 8. Friends, here he has already confirmed that these three numbers, n square minus 33, n square minus 31 and n square minus 29, are prime numbers. Okay. So before going for the solution, we should know a very basic fact regarding prime numbers, the triplet called 3, 5 and 7. It's a very important triplet because 3, 5, 7 is the only prime number triplet in the natural number system. 3, 5, 7 is the only prime number triplet where the difference of each consecutive prime number is 2. 3, 5, 7 is the only triplet where you can find consecutive. 3 and 5, what is the difference? 2. 5 and 7, what is the difference? 2. So 3, 5, 7 is the only triplet, that means the only set of three numbers that you can find in the natural number family, where if you calculate the difference between the consecutive prime numbers, that means first number and second number, what is the difference? 2. And then again, what is the difference between the second number and third number? That is 2. So this is the only triplet you can find. So nowhere in the natural number system this triplet is possible. So this point will help us to solve this question now. Okay, now he has given that n square minus 33, n square minus 31 and n square minus 29, these are prime numbers. He is already telling that he has already declared that these three numbers are prime numbers. So clearly, my dear friends, here n square minus 33, 31, 29. That means the difference between 33 and 31 is 2. That means if you add 2 to this number, you will get this number. Am I right? If you add 2 for this number, you will get this number. And if you add 2 to this number, you will get this number. N square, that means I can say like this, n square minus 33 plus 2. That means n square minus 31. So if you do plus 2 for this, n square minus 29. Okay. So can I say like this? I am taking this whole number. That means n square minus 33 as p, some p, prime number, because he told that he is a prime number. Now this one can be expressed, this number can be expressed as p plus 2 and this number can be expressed as p plus 4. Okay. So clearly these three numbers should be such a numbers. You take a prime number, immediately you should get some other prime number by adding 2 and to this prime number. That means if you add this, if you add 2 to this number, you should get. That means the consecutive difference between the prime number should be 2. And we know the only triplet possible like that is 3, 5 and 7. So p ka value 3 hona padega. And p plus 2 should be 5 and p plus 4 should be 7. This number, this n square minus 33, this n square minus 33 should be 3. So n square is equal to 3 plus 33. So n square is equal to 36. So n is equal to 6. N is equal to 6. N is equal to 6. The value of n should be 6. Option C is the answer. Option C is the answer. Okay, the value of n should be 6. So then only you can do like this. That means n square minus 33, n square minus 31, n square minus 29. So 36 minus 33, that is equal to 3. So 36 minus 31, that is equal to 5. 36, I am just verifying it. 36 minus 29, that is equal to 7. So again you got 3, 5 and 7. So the value of n should be. So we solved this question very easily because we already know that 3, 5, 7 is the only triplet, only prime number triplet where you can find the difference between the consecutive numbers as 2. So that's how we solve this question. The answer will be 6.